It's a great pleasure to introduce you to this panel where they have given us the very, very easy topic of figuring out the future development of artificial intelligence. I'm very honored to have a great set of panelists help us figure this out. Michael Levitt, Barbara Grosz, Stuart Russell, and Harry Shum. And it's great to have this diversity also, where we have both pioneers on the academic side of artificial intelligence, like Stuart Russell and Barbara Grosz, who are both doing artificial intelligence research basically just after I got out of diapers, or actually, well, when I was between 6 and 8 years old. And at the same time, having this wonderful industry perspective from Harry Shum, who leads up Microsoft's technology development, and also from the perspective of using computer technology to do wonderful science, like Michael Levitt, who's dabbled a little bit in chemistry, picked up the Nobel Prize for fantastic use of computers to understand nature better. So, as we take on this very large question of the future of the field of AI, let's try to structure it a little bit by starting with a near-term future, and then towards the end, go farther afield and think about more long-term questions. So beginning at the near term, we all know that on one hand, Ray Kurzweil gave us this very optimistic picture this morning where you have this curve, steady progress, it's going to keep getting better. And at the same time, a lot of people talk about the sociology of the field having gone through maybe 3 cycles of huge hype and then a lot of disappointment. So my first question is to each of you, if you could just briefly comment, 5, 10 years from now, do you think you will then be celebrating the continued awesome progress of AI, or that you'll be complaining that we're stuck in another AI winter? Do you want to start
I can start, and maybe I continue what I mentioned in the morning. I would say you look at AI, look at the various subjects of AIs. I would say in 5 to 10 years, for sure, speech recognition, we see the computer recognition of the speech will be just as good as what we can perceive as human. I think 10 years maybe are still a little bit of stretch if we think about computer vision, visual recognition of objects in different kind of categories, but we're probably getting pretty close. General AI, I think, is still a long way to go.
Stuart?
So I like to think that we will finally see some real progress in robotics. And to some extent, it's been a chicken and egg that there's been a very difficult mechanical, physical problem of building robots that have lightweight, rapid, flexible motion, that have sensitive skin, that have all kinds of sensors that enable them to be very dexterous. So there's been this sort of very slow improvement on the physical side, and it's hard to invest on the physical side when the robot algorithms are not there to use it. So if you've seen the recent DARPA challenge for humanoid robots,
when the MIT robot did a face plant, don't remind me.
I mean, they spend most of their time trying to get up after they've fallen over. So I think we should actually go to 4-legged robots rather than 2-legged. But with the progress in computer vision, I think that it starts to become practical to put robots into unstructured environments, which could be agriculture, which could be into the domestic environment, where current robots are extremely efficient in manufacturing and other situations where you can design the environment around the robot so the robot doesn't have to be intelligent to do its function. So that's one big set of problems that I think we'll really see progress on. And the other, I hope, is going to be the real understanding of language. So speech is a wonderful thing to be able to turn into text, but if you don't understand the text, then the world's best speech recognition system is completely useless. So the real understanding of language means not that you can process 100 billion pages and and count how many times the word Shakespeare appears or something like that. It's that you actually, even if it's just a page, that you can really extract the meaning and answer detailed questions about what was said, why was it said, how does it relate to information taken from another document. If that takes place, with one page, then very quickly you'll see that scale up to 100 billion pages. And then you've got machines that have read and understood, to some degree, everything the human race has ever written. And that will be a capability that we can only begin to guess how important that would be. It would put search engines, Google, and so on, into the shade as a technical advance.
So we've heard lots of optimism here, both from Harry and from Stuart. So, Barbara, are you going to pour cold water on them and warn of an AI winter, or are you going to share their optimism?
So I want to thank you, Max, because I brought this crystal ball here,
Awesome.
just in case somebody asked me to predict the future.
That's very cool.
And it's not telling me anything. And since, but thank you for making it worthwhile to have dragged it. Since in 1975, I predicted that by 1980 we would have solved the dialogue problem, I've given up making such predictions. I actually had a full plan for it. I did means end reasoning. Well, we need it in 1980, so we must have this by 76, 77, 78. So I think, so first of all, I agree with what in some sense, both Harry and Stuart said, but I would add one thing to it, which is if we take seriously what we talked about in the previous panel with human-computer interaction, and also take seriously that we're not trying to replicate humans, but instead to augment them, I think we can take many of the partial solutions that Harry talked about and combine them with well-designed interfaces to really increase what people are able to do. And here, I mean both what people in their everyday lives can be doing because the machines are enhancing them, but also what scientists can do in their own work, which I think actually is a good segue over to Michael.
Yeah.
Thank you for the
Give us your
segue. I
perspective.
have to get back to the original question about the ups and downs of artificial intelligence. And I think you get an up and down when achievements don't match expectations. And I would say instead of blaming the achievements, blame the expectations. For some reason, the word artificial intelligence leads to hype. And this hype is not always achieved. Very often also things are achieved that weren't expected. I find it quite difficult to distinguish between computing, artificial intelligence, big data. It's all just using computers to do things. So for example, computers could multiply faster than I could, probably in 1935. Well, I wasn't around then. But I didn't feel, no one feels bad that computers are better at multiplying. Playing chess. 10 years ago, computers were the world chess champion. Chess is still a very popular game. Now, obviously, if you had a cheating computer in your pocket and you played chess by cheating, that would be no different from taking drugs when you're in the Tour de France or something like that. It wouldn't be allowed. So I think this whole issue about computers sort of suddenly getting up and putting us down, it'll happen if we want it, but we don't have to have it happen. So I think that, I believe that there's going to be a rapid advance in computing. I'm not sure exactly. I think robots are going to be terrific. What I would love to see in the area of robots is a $1,000 robot that can make an omelette on my kitchen counter. Okay?
That would be
that
good.
shouldn't be that hard. It's the sort of thing that Kickstarter could maybe do. But in other words, get robots, the way that personal computers are out there, get out personal robots that go beyond the Lego Mindstorm that actually can do something useful. This should be possible. That would immediately change the whole area. Things like that, anyway.
I want to just address something Michael said. I think he's spot on. The challenges we have seen in AI. What's really happening right now, what's really progressing in the field the recent years is really because three things. One is computing is getting incredibly fast and cheap. Two is, this is very, very important, is actually we have more and more data that we can learn, like speech, like vision, that we can learn. Of course, we also got very lucky that we have some breakthrough in some latest algorithms, like deep learning and other things. Those specific things, I think, made a lot of this kind of progress today, becoming a reality. As you talk about this kind of $1,000 robot can do some general things, that day probably will come. I don't know how many years. Ree probably can tell us exactly which year, but we probably are not that sure. So the way you think about this, where we actually still face a tremendous challenge is actually our inability to model uncertainty. Things we actually don't really know. a lot of this kind of big data, machine learning thing is actually trying to look for something common among the data. But what we really don't know, let's just say, which robot is more difficult to design? Is a flying drone, landing or aircraft carrier, or actually a little robot moving in your house? I would argue it's the latter. Yep. The reason for that is we actually don't really know how to model this kind of uncertainty in different kind of houses, from Sweden to US to China. So those things that we just don't really know. So those are the most difficult problems, I think, as I think about next 10, 20 years of research.
So I also want to pick up on the managing expectations, because I think that that's a very important thing to do. That, and what Harry said about the big data and the faster computers is absolutely true. But of course, the results are only as good as the data that they have. And there are some problems for which either large amounts of data are not available, or for which that's not going to be sufficient. But there are already, I just was reminded by what people were saying, Milintambe has this very nice work that we wouldn't, so you asked to predict. In 2007, no one, I think, would have predicted that Stackelberg games from economic theory would make a difference in security. And yet in Malaysia now, those Stackelberg games are being used to protect wildlife in the forests by doing something which people are not good at, which is understanding uncertainty and randomness and predicting where the poachers are going to be. So that's an example of something that's here now that wouldn't have predicted. Okay, that's 8 years ago. I think it's very, very hard to predict if you're not trying to create the Ava of Ex Machina, which I'm not sure we want or need, but instead trying to take the ideas that we have and show where they can make a difference in the world.
Yeah, those are really interesting points you make. And Michael, I think you said it very well there, where you said that what we should really blame for these disappointments in the past is not the progress, which has actually been quite impressive all along, but rather our expectations that we let get completely out of sync. As the moderator, I feel it's my job to be the devil's advocate. So with all this optimism here about how fast the technology will progress, I have to ask nonetheless, how can we be so sure that this time is different? That this time all the optimism and the expectations of how great things are going to be in the next 5, 10 years are actually realistic and not, again, wishful thinking brought on by good Swedish food and so on.
So I would draw a different curve, which is that the progress has been like this, and that there are breakthroughs in what we understand algorithmically, there are breakthroughs in material science, there are breakthroughs in many things. And I think that a big difference now from the 1980s, when I first saw these great, well, we'll leave out the 1960s, the 1980s, is that there are AI systems out in the world now making a major difference in people's lives. There are recommendation systems, there are search engines, so it's there. So now there's a sense in which we can just do more as opposed to having to do something.
Yeah, I think if progress gets to the point where, for example, in speech recognition, where it becomes more valuable to a person to have a speech recognition system, even if it's not perfect, then it's just painful. It used to be just painful to use a dictation system because they would make more mistakes than it would take you twice as long to fix. So once it crosses that threshold where it has real economic value, then every extra 1% in terms of performance is worth billions of dollars. And so this virtuous cycle takes hold very quickly in terms of investment from industry. And I would say in the last 5 years, the investment from industry has dwarfed what government has put into AI in the previous 50 years. And that really makes a difference. The second big difference is that in the previous cycles of hype, a lot of the claims were based on shall we say, flimsy technological grounds. There was a very, very thin and almost non-existent theoretical basis for a lot of the systems that were being built. And now the nature of the field has changed completely. So I'm sorry to say, for those of you who think you might enjoy going to an AI conference, that it's essentially hard to distinguish from a mathematics conference. Just slides and slides and slides full of equations and proofs and results and complexity and all this sort of stuff. So the field has become very rigorous, very solid, and that has resulted in this type of progress that you see in physics and chemistry, where you're building on decades of really solid mathematical modeling and theory.
So we're hearing.
I actually agree, with Stuart said. But as a practitioner myself, I work in industry. If you work on the products, you actually are required to make progress, at some predictable rate. I have been listening to a lot of thought leaders today talking about, predicting the future. This is how I think about. I think that the progress of AI will neither be linear nor exponential. I think it's probably going to be more like a spiral. I think linear is too boring, exponential is too optimistic. I think the reality is probably more like a spiral.
Just going into multi-dimensional space.
It's all mathematical. It's all mathematical. Those curves are only two-dimensional. Mine is at least 3D. So.
Yeah. No, I think actually the multidimensional is exactly the right point. That there is no machine IQ,
right.
And there's no way of measuring progress of AI in a single number. Humans, to a rough approximation, have an IQ, which means that if someone is good at, for example, translating between multiple languages, they're probably also good at writing, and they're probably also good at reading and answering questions. None of those things are true of machines. So the world's best chess-playing program can't play any other game at all, even at the level of a one-year-old. Systems that can translate among 200 different languages, as well as any human being, can't read a book to save their lives. They can't answer a single question. So they're totally unlike human intelligence, and they progress along many of these dimensions, hundreds of dimensions of progress, where they could go along sort of long corridors of advancing in these very narrow directions that make systems that don't look anything like a human being, but are super intelligent in a very restricted sense. So they might know more than, in a useful sense, they might know more than any human being has ever known or will ever know. But they still couldn't plan their way out of a paper bag.
Or still can't make a nice omelet for Michael. Yeah.
Yep.
So now that you've been all very cautious and heeded Barbara's advice that her crystal ball doesn't really work, and made these guarded, optimistic statements about the future, let's now throw all caution into the wind here. Because now I want to ask you, suppose we actually give ourselves license to engage in some wishful thinking. I'm very curious for each one of you to hear, what is your favorite AI-based technology or application that you would really love to see come to fruition, say, over the next decade? And how would you like that to impact your life and society?
So let me start. So what I would love to have is that use of an expert system like Watson would be compulsory for all politicians before they make any decisions. And that this would be recorded like a police camera, i.e., George Bush would go to the machine and say, invade Iraq, and if Watson didn't say yes, 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 then he'd have to say why he did it against Watson's decision. And the good thing is that, when you're kind of powerful, all your advisors just tell you what you want to hear. Presumably, artificial intelligence would be smart enough not to do that. So I really think this is something which I somehow feel that simulation, government things are much harder than the problems we have in biology or chemistry by any level. And they need to be tackled by similar methods. Simulate what's going to happen. Simulate, let Syrian refugees into Europe. We don't let Syrian. What is going to be the outcome? And follow it through, not half a move ahead, but 10 moves ahead, like chess. And actually look at the implications. People don't ever do this. And this just seems to me to be, they're basically playing with our future. And I think this is something which one hopes would catch on, that in some ways, even just applying stuff which is pretty prosaic. One thing I was just thinking about is, so there are lots of different computer programs for guiding you in your car. There's a great one called Waze, and if you don't know about it, you should know about it. So basically, it basically breaks all privacy. Anyone using Waze is actually sending to the server where he is and what speed he's going, and therefore Waze can tell you exactly what you're doing because the car in front of you is going to do something different or similar. But what's really interesting about Waze is how it's a wonderful avoider of family arguments. I used to get into the car, my wife would say, you go the short way. I'd say, no, I want to go a new way. Now, if you go a new way, and you're delayed, it's your fault. If you go the sure way and you're delayed, it's all okay. So basically, you just simply say, we'll do what Way says. And I keep on thinking there needs to be artificial intelligence like that. So for example, some question at home, I don't know, change the curtains or something like that. You'd have something that would just tell you, change them. And after a while, you'd get used to them, and people would be much happier living together.
But I worry. So in our panel just an hour ago, we talked a lot about machines that need to use social and emotional intelligence to make people happy. So we may find that AI is just telling you what you want to hear. Anyway, yes, so your curtains are wonderful. Love them, absolutely love the curtains.
Yeah, to me, I think the most exciting thing, looking into the future, really thinking about AI, is really this all-knowing agent for you. And I think there's this Greek term called alter ego. It's really about your second self. It's about yourself. But I think it does require the users to be willing to cooperate, to cooperate with the AI system such that we actually have a chance to build the AI. It's very important. Just take the Michael's example. Say, what kind of advices do you really want to get from your alter ego, from your AI assistant? You really want that to be very personal. But you can only build that if you are willing to share with your AI system what you like. Only Michael knows how he actually every day interacts with his wife. We're probably doing very different. I programmed myself a long time ago, whatever my wife says is correct. So that's important. That's the harmony for the family. So that's the principle. But everyone's different. So you have to program yourself such that you actually have this. Then you get really the right advice and other things. Again, I'm a big believer in having the data and having the computing to actually help you to get the AI right. To me, I think this alter ego thing is the most important and exciting AI system in the future.
Very interesting. So what's your wish?
So now that we have these dreams of solving all of international politics and domestic discord, it's very hard to think that anything is left, or anything will sound long term. So I'm feeling like my fantasies are rather mundane, but I really do hope to see them realized. And one of them is actually related to what Michael said, which is to provide advice and expertise to not just to governments and people governing, but to enhance people's ability to participate in government and to bring what people at large care about to the people who are governing. So to make that kind of change. And then related to some of the healthcare that I talked about before, I would like to see an intelligent system that really helps a team of doctors become a team. And that raises a number of enormous issues, one of which I talked about earlier, which is what information to share with whom when. But it also, both of these actually bring up an issue which we may want to talk about more, which is the issue of when you shift from a computer talking about taking charge of something to a person taking charge of something, how that handoff should happen and when, and what information should get conveyed there. So.
Great. And Stuart, so now that you have not the crystal ball, but the genie in the bottles, you can make wishes. I know you warned us about genies this morning, but if you get one wish anyway for some great AI-enabled technology, what's your pick?
I think one of the things that machines can really do for us in the relatively near future is to collect and synthesize much larger amounts of information than we can handle. And I can think of two examples. One, which is quite close to Michael's interest, which would be the massive amount of information we have in molecular biology about the functioning of cells and organs, which is far too much for any individual person to understand. There are about 1 million papers published every year on these topics. And if you read any one of them, right, they name 500 molecules in the first 2 pages. So I think this is, just our cognitive capacity to handle this is a real bottleneck. So if we could use that information and use it to build a consistent picture, which wouldn't be a definitive picture because we don't have definitive answers, but it would represent the uncertainty that we have about information. Because one of the biggest problems that's happening in the life sciences and social sciences as well is that because of the publication process and selection bias for papers, it turns out that many major results on which people rely turn out not to be reproducible. Another way of saying it is they're wrong, right? They are false claims because you look for 95% confidence in your statistical results from your data, but if you submit 100 papers and only the ones with the biggest results get accepted, then probably most of those are going to be wrong. It's just a fact about statistics. And so that's one area that we could build a consistent consensus picture of what's solidly known, what's partially known, what's uncertain about the functioning of life, and obviously with applications for medicine. I'd like to do something similar, which is perhaps a little bit more off in left field, and I can't see that there's going to be huge amount of government investment in this, but actually to do the same thing with history. That you can find journals where people spend their whole lives looking at 12 clay tablets with some Assyrian something or others written on them, and then there's another journal where some other specialist ancient language works, and there are many of these silos where there's incredible expertise, but there's no cross-fertilization. There isn't the ability to put together this information and actually understand what happened in our history. So this includes, for example, the evolution of language, the movement of peoples, from genetic information, from artifacts, from text, from all kinds of sources, which could be a wonderful way of learning about ourselves, our own histories, and how we've all evolved over time, and our cultures have grown and interweaved over time. So I think that would be a really fun thing to spend one's life on.
Thank you for all these exciting ideas. I hope they all come true, and hope Jeannie grants them and they go well. During the remaining 10-15 minutes we have here, let's come back to this very broad charge that we were given by the organizers here to talk about the whole future artificial intelligence and look farther afield here. This is, of course, where we have even less knowledge and it becomes more a matter of speculation. So before we get into any details and hopefully interesting disagreements, let me ask you just a very, very simple question, which you're only allowed to answer with one word, which has to be a number. Okay, so the question is, how many years from now will machines be able to actually match human ability on all cognitive tasks? You can say infinity if you think it's never going to happen. By all cognitive tasks, I mean not only playing chess and translating French into Mandarin, but I also mean making a really good omelette that you approve of if you plug the machine into a sufficiently good mechanical system. So you can say a number between 0 and infinity for when you think there's at least 50% chance that we'll have across-the-board human-level AI. Do you want to go first? And then you'll have a chance to qualify it afterwards.
I have a question.
Yeah.
You won't be too surprised by this question. But everything you mentioned was a kind of subject matter issue. Are you also asking about machines that are going to be good psychotherapists and friends, or are we leaving that set of human capabilities, as I hope, out of the equation?
I'll leave it up to you to make your own definitions, but I would be very broad and say that's absolutely a cognitive task because we do it with our brains when we're psychologists. So if you think machines cannot do that, I would say
you're including the hypothalamus.
Everything. It works. So just say one number really quickly, and then it'll be very interesting to see if there's a big spread.
300 years.
300 years. What about you?
Infinity, because I wouldn't include the hypothalamus.
Okay. And what about you?
Okay, I'm not going to give a number.
You're going to punt.
So the last time I was asked to give a number was in an officially off-the-record session where journalists were not allowed to take notes, let alone report anything. And so I said, off the record, possibly within the lifetime of my children, one of whom sitting in the front row there. And within 20 minutes, the Daily Telegraph reported, scientists predict robots will overrun the world within a generation. I kid you not. This is the literal truth. So I'm very wary of giving a number.
But even though he diplomatically didn't say anything, he did convey interesting
Max,
information.
he even consulted my crystal ball, and he still won't have a number.
All right. And last but not least, what's your number, Harry?
Well, I think those people are not answering your question. I think if I'm not asked to build this kind of system, I would say, if I understand your question, we're really talking about 50 to 100 years that we may be able to build this kind of capabilities.
Okay. And then we have one more number from Ray Kurzweil, who spoke this morning. He's been talking a lot about 2029, which is 14 years from now, plus give or take a little bit. So this is very interesting because, of course, the worst nightmare when you're in the audience is to sit and listen to a panel where everybody just agrees with everybody else and like, yeah, and you get this mutual admiration society going and you take out your laptop. That's not the case. We're very fortunate. We had infinity. We had 50 to 100 years. We had won't answer, but probably in Gordon's lifetime here, and 300 years. So why don't we each go around and
I think you should go this way.
Do you want to start here? Yeah, why do you think infinity is too big? Why are you more optimistic than Barbara that we're going to get there?
I think you never say never. I think you just have to really look at that, from somewhat a scientific point of view. You look at the data you have, then you make certain predictions, and hopefully you have a couple of chances to iterate and verify and see what's going on. I think I have been very encouraged by the progress in this AI field. 25 years ago when I started working in AI in robotics in graduate school, it was kind of the beginning or the middle of that AI winter. People would say, this speech thing will never work. You look at this error rate will never really drop that fast. But I see that a lot of opportunities there. And as Stuart earlier mentioned, that there are good reasons why now is actually also a good time to push things moving forward. I do believe that this progress will be more spiral. We don't really know when it will be a big jump. I think there will be tough scientific research problems such as modeling uncertainty, general knowledge representation. Those problems we have to address. I'm afraid that I wouldn't be able to see that in my lifetime. So I feel very comfortable predicting any number when I'm gone.
And do you want to push back on this? You said infinity. So there's clearly something you think that he's over-optimistic about that's going to turn out to be beyond.
So I advisedly asked this question about the hypothalamus and about emotion and about psychotherapy, because I think, it's also an ethical question.
Right.
I think there are things that human beings owe each other, and we talked about this in the previous panel on human-computer interaction. There are things that we shouldn't delegate to machines. So if you want to leave those things out of the mix, then one could answer a question about the kinds of intelligence that we think we might want to delegate to machines, and when will they surpass us? Then I would say they already have in search. They're much better at searching than I am. They've been better than us at arithmetic for a long time, and I think we will. I think we will continue to see AI and intelligent systems doing more and more things in the domains in which machines can be more intelligent than us, in perpetuity now.
So just to clarify,
I don't want an Ava from Ex Machina. So I don't think this is a reasonable, practical goal.
But Google does. Right? Google DeepMind says their goal is to build a superhuman general-purpose intelligence. And there's 550 highly trained people sitting there in an office building in London doing exactly that. So this is the question, right? To some extent, it doesn't matter what we want, because people see, I think Google from the beginning has seen its goal as to have superhuman AI capabilities as a massive economic asset, that this would enable them essentially to control a large part of the world economy.
But do they really mean to replace psychotherapists?
I think they don't see that as a big part of the world
Yes, so
economy.
that's-
So possibly,
So you're
possibly not.
So to answer Max's question,
Yeah.
he's not really disagreeing with me. He's changing the topic.
So just to make sure we're all on the same page, and to clarify here, Michael has, to great success, managed to simulate quite complicated molecular systems. Suppose in the future, thanks to Moore's law, Michael simulates the entire hypothalamus. Or suppose some other person in 500 years simulates your entire brain. Do you think that that system would then, by definition, be as capable as a human, except in silicon? Or do you think that, in other words, did you guess infinity because you think that it's fundamentally impossible to have human level AI? Or did you say infinity because you think people will choose not to build these things because we shouldn't? Which of those two
So, you know, I
was
always say to my students, I love or questions because then I can say yes. But I said infinity for the second reason.
That you think we shouldn't go there, and you think we therefore
Yeah, I mean,
won't.
I'm not. I think there are many great directions to go with intelligent systems. I should say I don't actually like the label artificial intelligence, with all due respect. I prefer machine intelligence and intelligent systems. And I think they will become more and more powerful, and they will complement us in many, many ways. And that's really how I mean, if you want my prediction for the future, that's my prediction for the future.
Very interesting.
Rather than replacing us.
Yeah, and Michael, you said 300 years. Is this because you think, again, that people will not want to go there, or because you think it's going to be very hard?
This was the opening bid. So, you know, being in the pole position, I really like Barbara's idea about just things you don't do. And in the same way that we don't clone people, we really perhaps should, and again, when you talk about a computer that is indistinguishable from a human, this is like a super Turing test. So I would live with somebody for a year, and then I would know whether they were a person or a human. What is it going to be? So I think that I don't think it's actually that interesting. I think it's exactly I think the key thing is how we're going to use. What worries me much, much more. Let's just imagine that in 10 years' time, you can make troops that are robots that are basically invincible. You know, maybe this is an answer of the enlightened world against the non-enlightened world. It's a terrible answer. You know, I just don't know. But in the same way, we don't use chemical weapons. We hardly use nuclear weapons. I think that there needs to be limits set. I also find it quite difficult to distinguish between artificial intelligence and computing. So, for example, is my iPhone an artificial intelligence device? Is it an interface device? Is it a calculating machine? My feeling is that it certainly augments my intelligence. And as such, I'm very happy to see it as artificial intelligence. So, I think that there's no doubt that computing is going to become more and more important in everything we do. And I hope we can really get things better. I think the fact that world poverty has fallen by a factor of 2 in 25 years, which is unbelievable.
Yeah.
I hardly even believe the numbers. I bet that has a lot of technological input to that.
Those are really nice perspectives, and we have a lot, certainly, to be optimistic about there. We're shortly going to go to some audience questions during our last 5 minutes. Just to spur you in the audience to ask questions, let me ask one last quickie round at all of you here again. So we saw a poll this morning where about 2/3 of you here in the room guessed that we would get human-level artificial intelligence in this century. So let's for a moment give our audience the benefit of the doubt, regardless of what we said here on stage. Suppose sometime in this century or even later, we do get to human-level intelligence. Then my question is, and here again you should just say a number for your answer. On a scale from 0 to 10, how do you feel about this? How concerned do you feel? Where 10 means you're really quite concerned that it might go bad. 0 means you're absolutely not worried at all, and you feel it's sort of guaranteed everything is going to be fine. So suppose they're right, we'll get human-level AI at some point. How worried are you? 0. All right, an optimist.
If by human-level intelligence you mean at least the ethical standards that most human beings have, then I'm not worried. If you mean that we're just creating intelligence in some other abstract sense with no, as Stuart would actually refer to it, no value system, but I'll say no ethics built into the way it operates, then I would be very concerned.
Okay. Stuart?
7, so I think I would echo what Barbara said.
But you were being good and gave him a number this time.
Yeah, so coming back to the question of robots, invincible robot soldiers, this is, I would say, balanced on a knife edge. We could see within 5 or 10 years that most of the major powers are actually operating their defense systems largely using autonomous weapons, which I think could be extremely unstable and a quite dangerous situation.
So would those weapons be able to take Iraq? I mean, would they not just fight bombers, i.e. go in there and occupy territory?
Yes. I mean, you could imagine
you could deploy
using
20,000 such robots who would go in and...
Yeah.
I think it requires a lot of coordination.
I want to just make sure that Harry gets his good say before we go to audience questions.
Just to clarify, 7 means actually he's really worried about.
But he clearly has a hope that we can get things right.
Yeah,
he didn't say 10.
Yeah, he didn't say 10. No, then I'm exactly 10 minus 7. So I actually go 3. I would say, of course, we should be worried about. And I actually was talking to Barbara at lunchtime. The ethics concerns we should have as we develop this kind of technology, especially on the emotional side with human being. And of course, with this kind of powerful technology, potentially, powerful weapons and other things we mentioned about with robots and with AI. We have to be very careful, how we actually use this kind of technology, just like how we actually use nuclear weapons. Those things,
right.
Just you cannot go all the way down to 0 at all. So you have to be concerned.
Okay, I want to just give the audience a chance to ask a couple of quick questions before we don't want to be the ones standing between them and coffee. That's not good. So we have microphones out here. Make sure your questions are brief and that they actually are questions, not statements. And we'll try to answer briefly too.
So, Max, can I say something?
Yeah, while we get the question. All right, go for it.
I want to pick up on something that Michael said, which is he thinks of AI and computing as the same thing. And as we think about the risks, the risk of cyber warfare, of cyber security, permeates all of this. There's also the risk of the handoffs that I talked about, and there's the risks of buggy code, which also permeates all of this. So I think that the fact that AI and computing are so closely intertwined means that the risks are closely intertwined as well.
Yeah, very good point. So quick questions, and we'll try to do quick answers and squeeze in a couple. Who is the keeper of the mic? We'll start by saying your name and also who you are.
My name is Axel, and I'm studying cognitive science here in Gothenburg. And I hope I can frame this right, but do you believe that artificial intelligence or intelligence machines must have a human form or a human element for us to be able to interact well with them? It's a bit of an interaction question maybe, but yeah.
Who feels most eager to field this one? We'll just do one person for each question since we're out of time. Who wants to take this?
So the answer is no, that computers can interact quite well with people without pretending to be people. And on the previous panel, we actually talked about how important it was, or several of us talked about how important it was to be able to interpret what people's emotions and their state, but to also be clear about not being a human when you communicate back.
In fact, I would like to propose a ban on robots that are too humanoid. I think they should be morphologically distinct from humans, maybe have 4 legs and 2 arms, so that they're not fooling us, because I think it's really a form of dishonesty to put something in a human form that just isn't human in any way.
Good point. One last audience question before we go for coffee.
My name is Fredrik Heinz. I'm the president of Swedish AI Society. I'm curious to know what areas of AI do you think is underdeveloped? We have a lot of students in the audience, so what areas of AI is underdeveloped that you would see more work on?
All of them.
I give you a very quick answer. I really think that today there's a huge concentration of certain specific areas like vision, like speech. I really hope that we have more brilliant students to study the general knowledge representation. I think this is really very, very important. If I may add one more thing, I would also say there are just so many very important AI applications that we should also study. My current favorite is actually for medical applications. If you think about that, in the United States alone, every year 400,000 people die of preventable errors, medical errors. With the data, with the computer, with the AI technology, we can save a lot of lives.
Great, lots of optimism there. So to summarize, we've heard from our panelists here that there's quite uniform optimism in the near term, a lot of great possibilities, and this time we're not going to get an AI winter because it's happening. And looking a little bit farther afield, we saw again great prospects for wonderful things coming out of this, as long as we don't do stupid things. And I think the clear message was here that which all of you really nicely phrased, is when you said it's going to be a 7 if this, otherwise 0, is that we shouldn't think of the future as something that's going to happen to us, as if we're just pathetic, passive bystanders who have no impact. We are the masters of our own destiny. We are shaping our own future. And I think an optimistic end note to take away from what we've heard here is that we should clearly figure out what sort of future we want and build that one, not the bad one. So let's thank our wonderful panel for a really stimulating discussion.